it's my great pleasure to introduce you to Dr. Alex Jinsung Choi. Alex is Senior Vice President of Strategy and Technology Innovation, Head of T-Laboratories Innovation, and member of the Technology and Innovation Management Board at Deutsche Telekom in Germany. Prior to joining Deutsche Telekom, he served as Chief Technology Officer and Head of the Corporate R&D Department and the Technology Strategy Office at SK Telecom in South Korea. Before SK Telecom, he held various management positions at LG Electronics. Alex has more than 20 years of experience in the mobile telecommunications industry and was responsible for the implementation of the first commercial 3G network in Korea. Today, he will discuss how internet growth and the dawn of 5G will bring new requirements to optical networks. He will ask us to rethink the way networks will be architected and built in the future, and he will look into the shift towards disaggregation and open platform innovation. Please join me in welcoming Alex Choi.
Thank you, Jörg, for your kind introduction. It's such a nice weather outside. Good morning, ladies and gentlemen. It's really my pleasure to be here today at OFC conference. I really thank OFC for that. As briefly introduced, I moved from South Korea to Germany about 1.5 years ago to join Deutsche Telekom. This career change is very unusual because there was no previous case of South Korean working for the major international operators at executive level. I think I'm very, very fortunate. So my presentation is about open innovation in 5G. So let me begin by saying a few words about my company, Deutsche Telekom, or DT in short. Currently, DT is operating in more than 50 countries worldwide with 75 billion euro revenue last year. We have about 168 million mobile customers and 28 million fixed network lines and 19 million broadband customers. Total number of employees worldwide is about 217,000. We own extended fiber backbone in our European footprint. We have been pushing very hard our fiber rollout, particularly in Germany. Our IP migration has been completed in 5 EU netcodes already. We have won all relevant public network tests, such as Connect, P3, Open Signal in our footprint. Last but not least, we drive network innovation with 5G and edge computing. So 5G gets a rear for DT this year. Depending on spectrum auction result, we will start to roll out 5G network in our European markets from this year as part of capacity and speed enhancement, starting in selected areas such as cities and campus networks. The first 5G deployment will be as an overlay network on 4G based on non-standalone standard. To ensure a great user experience from the get-go, our focus now is on readiness. The whole end-to-end chain will be impacted from terminals across radio, transport, core to the related IT systems. Regarding 5G economic rationale, our belief is 5G will be more efficient than 4G from 2021 onwards. Also, 5G will enable new revenue streams in selected areas such as massive IoT, low latency connectivity service, and campus networks. 5G can also be a good option for fixed wireless access. 5G will enable new services such as assisted automated driving, new AR solutions, Industry 4.0 applications like remote robot control, massive video distribution, immersive contents, asset tracking, connected drone, and etc. 5G operators need to take care of following 5 technical challenges to make their 5G services as common use cases. So let's dive into. I will go from left to right. First, exponential traffic growth. As mentioned by many professional organizations, including Cisco, traffic growth will reach 5 zettabytes per year by 2022, based on the current annual growth rate of 25%. Zeta is a 10 to the power of 21. That's enormous. What's more complicated is that the busy hour traffic increases even faster than the average traffic. The video traffic played a major role on such increase. The problem is that operators' output does not increase on par to the traffic growth, which creates a gap that must be closed with new technologies. Second is the total investment cost for the 5G radio access network. 5G uses high-frequency band like a 3.5 gigahertz on top of existing bands compared to 4G to secure broader spectrum range. As a result, 5G requires a larger number of base station antennas to match the service quality, which is a giant cost by itself. Adopting a more open and standardized base station can be a solution by increasing economies of scale and by better accommodating the innovative technologies for cost reduction. Third is front haul and backhaul for 5G. I'm sure this is a topic that all of us in this room are very much interested in. Currently, 3GPP offers diverse options for splitting the baseband processing between the RU and DU. All of these options create different front haul requirements, resulting in a wider range of front haul options than 4G LTE. Operators thus can choose the best options according to their 5G network rollout strategy. Such flexibility is no doubt desirable, but it can also complicate the operator's 5G network operation, which creates needs for automation tools to solve the problems. Fourth element is energy efficiency. 5G uses diverse active array antennas such as massive MIMO, which increase energy usage. Increased energy usage is a burden on the operator's 5G network OPEX. Any creative solution for energy efficiency of resources would be more than welcome. The last but not least is a service deployment flexibility. As you know well, the agile service development environment, such as DevOps, is the trend on cloud-based IT infrastructure. On the other hand, similar efforts by the operators, such as the service virtualization efforts, are still far behind. In other words, the delay between new service requests and the actual delivery is much longer for operator services, resulting in the low service competitiveness. Therefore, operators need to accelerate the execution of service virtualization and develop technologies that can free from the legacy systems. This slide a little bit busy. This slide speaks of technical challenges from a different point of view. In addition, it contains the key issues in the mid to long-term viewpoint of operators. Let's start with the network diagram consisting of five layers on the left. As shown, the network consists of, from the bottom, access layer, IP layer, cloud and service platform layer, and control orchestration layer, which can form virtual networks on a global scale. At the top of the figure is the custom interaction and product layer. A close look at the picture shows that there is a colored border in each layer, which indicates that the physical infrastructure coverage of operators are limited in reality. First, let's look at the very bottom layer, which is the access layer. This layer includes all of fixed mobile, cable, FTTH that you all are already familiar with. As we will see later, this is a recent disassembly of data plane and control plane for RAN virtualization, and also softwareization and network flexibility through SDN and NFV technology and unification of different access technologies are really happening now. In particular, lambda switching or wavelength switching technologies are increasingly expanding from existing IP backbone and backhaul to the front haul of metro and mobile networks. The reconfiguration, programming, and automation on lambda levels, known as photonic fabrics, will be an essential feature in 5G. Second is the IP layer. This part corresponds to the network of current IP routers and is the area where IP packets are switched according to the various IP routing protocols defined by IETF. Especially as the SD-WAN, software-defined WAN technology, and the related markets are gradually expanding, innovation in the IP routing technology is expected, which will evolve into a more open layer in the future. Third and fourth layers are the cloud and service platform layer and the control and orchestration layer. These layers can be seen as the focus of development and operation of all telecommunication services of the future, as the operator network is gradually being virtualized. All legacy data services and IP-based voice messaging services are made right here, including low latency video services. In other words, these layers are the most essential platform for all service providers, including operators, and will cause the most intense competition in the future. These are the so-called OTT layer, where it's allowed to access to neighboring markets without physical access infrastructure, thanks to virtualization and software-defined network technologies. The concept of network slicing in 5G will also be realized through this layer. However, due mainly to the lack of the final version of 5G standalone core network standard, we would need to wait a little bit more for the commercialization of real, true network slicing. Now, let's have a look at the right-hand side, the billion-dollar questions to our 5G ecosystem. Number one, how do you see the value chain development in the different layers? Number two, where do you see global operators' right to play? Number three, what are the key technology enablers? And number four, where do you see your value add? We have the answers to some of these questions, but all these questions require constant considerations by all stakeholders in the ecosystem, including us. In this sense, rather than discussing the detailed answers to these questions right here today, I recommend you all to take these questions home and ponder for answers. Now, let's talk about the importance of openness in communications and networks, and the importance of orchestration, which further links each building block from the left to the right. Based on the necessity aspect, openness is inevitable if we take into consideration the communication network itself and the various current and future services running on top, as well as industry-wide ecosystem related to the network. The problem is how open we will be and who will standardize the interfaces, setting up the reference architecture and standardizing the physical or logical interfaces for each building block, for example, by 3GPP or broadband forum or any other standard forum, is never enough. The contribution of open source community for actual implementation is crucial. Let's take a moment to review the shipping container industry shown in this slide. In our industry, containerization refers to actually the virtualization software technologies, not the shipping container. But let me use this shipping container industry as an example. They are different, but at the same time, they have something in common. The history of shipping containers is as follows. In the pre-1970s, before the container was standardized, half of the transportation cost consists of the simple labor cost. Many ports laborers spent a long time on loading various types of cargo. Such cost structure eventually hindered the growth of the whole shipping market. Once such a problem was cleared, thanks to the invention of a uniform, open standard shipping container in the 1970s, the entire shipping market enjoyed a rapid growth with the economy of scale these containers brought to the market. In other words, this is a great success case of standardization and openness leading to the market growth. The telecom and the network markets are standing on the verge of the inflection point with a sizable momentum. The decisions we take to accelerate it will determine whether it will bring success to both the market and the ecosystem. Good news is that various efforts are now being made throughout the ecosystem. On the right-hand side, I put the list of the organizations. They are the industry alliances working on such efforts. However, there is still a long way to go beyond the standardization stage, as the 5G needs to be deeply applied to telecommunication and network in earnest. To do so, we must overcome the final barrier of commercializations. A harmonization among these various industry alliances is critical. A mutually productive competition is desirable, but there is a need for a close collaboration to prevent confusion in the market. In addition, various forms of co-work between existing traditional vendors and startups armed with innovative ideas are essential. This is the final point that I would like to strongly insist today. Having said, let's deep dive some of these key open alliance activities. First, ORAN, or Open RAN. This alliance is newly founded last year after the merger between Global X RAN and the C-RAN, or Cloud RAN, in China. Deutsche Telekom is one of the founders of ORAN, and personally, I'm working here as a COO. Currently, we have 19 major operators worldwide, including Deutsche Telekom, AT&T, Verizon, Orange, Telecom Italia, China Mobile, China Telecom, major South Korean, Japanese, and Indian operators. We recently published our first ORAN specification in area of front haul. Moreover, ORAN successfully showcased 6 different use case demos at Mobile World Congress last week. This demo includes implementation of radio intelligent controller load balancing, AI-powered user quality of experience, programmable millimeter wave white box radio unit, and often front haul interface implementation, which are sponsored by Verizon, Docomo, SK Telecom, my former company, and etc. ORAN is also closely collaborating with the Linux Foundation networking community for their open source implementation support. This is a great achievement so far. And we are excited to see more throughout this year. The second, Telecom Infra Project, or TIP in short, sponsored by Facebook. TIP has been making efforts in various network areas to accelerate innovation and ultimately help operators provide better connectivity. One of their key achievements is open optical line systems, as shown in this slide. Another big achievement within TIP community is millimeter wave-based wireless networking solutions for operators called Telegraph. Actually, we call this project a virtual fiber in DT. And we co-led this innovation together with Facebook. We have already done 2 field trials in one of our DT European market, which is Hungary. The 2 field trial sites are Mikebuta and Marko, and the trial results are very encouraging. Particularly, we shortened the time to roll out dramatically by agile way of project execution. This is a great example of how our industry should work together in executing joint innovation. To know more about this, let me show you a 3-minute video.
Telegraph, it's a technology which is helping Magyar Telekom to reach customers with a fiber-like connectivity without digging.
You know, you want a fiber going through a street, right? You have to interrupt the traffic, trench the cables.
That could take years if you want to connect a complete city. This is what we call virtual fiber. It's fiber, but it's virtual because it's in the air.
Connectivity is a complex problem. I don't think any single company can solve it. We have done everything that we wanted to do in our campus, and now it's time to go out and work with partners to deploy this technology.
Mivel ugye egy internetvonalunk van, és azért 3-4 gép is megy egyszerre, így nagyon-nagyon nehézkes.
This is something which was long tested, and now we are actually proving that this can work.
The major point is how fast you can get your service up and running. Deploying Telegraph is very fast.
We turned the switch on and we connected the first user, which is Mayor's office in Mikebuta.
They literally deployed a network in 6 days.
That was the moment where I became convinced that Telegraph is a good approach.
We want to see Telegraph scale in large cities, in large suburbs.
It's a very clever idea because it provides more flexibility for a rollout so that you can be more demand-driven.
You can build a smaller scale network at first, and if you have enough market interest later, you can add Telegraph nodes off to the side.
I see the city with different eyes. Wherever I go, I look up, for example, would it be possible to mount an antenna on this lamppost?
This is something that everyone should have access to. And it just feels great to give this experience to everybody.
Once again, the customer feedbacks after our trial was really, really great. And I'm so proud of my team led by Dr. Andrea Gladish for making this happen. The next one is ONF, Open Networking Foundation, and CORD, Central Office Re-architected as a data center. Access 4.0 is our DT internal project name for this particular fixed broadband access network use case. We built a cost-efficient access edge out of open, commoditized hardware as well as open community software. The design is based on ONF SEBA, SDN-enabled broadband access, a lightweight platform based on ONF Verta. It supports a multitude of virtualized access technologies at the edge of the carrier network. I'm not going to get to the details here. Last but not least is edge cloud computing. I'd like to spend a few minutes to explain about the status of this project and the ecosystem on edge cloud platform, which draws keen interest from operators and is quite different from existing open alliances such as Orange. Deutsche Telekom is leading the edge cloud ecosystem developments with several companies in this field. For example, in last week Mobile World Congress, DT hosted a demonstration of a multiplayer AR, augmented reality game with the DT Cloud IaaS infra in Germany, and to demonstrate the success of the edge cloud in the consumer gaming market, along with major partners such as Niantic, the AR game company famous for Pokemon Go, Samsung Electronics, the mobile device market leader, and the MOBILEDGEX, a startup founded by DT in Silicon Valley to provide edge platform software. The role of MOBILEDGEX, the newly founded company which develops the edge platform software, was essentially important for cooperation between these four companies. As is shown in this picture, MOBILEDGEX plays a role of connecting cloud providers, technology partners, app developers, and device makers. The emergence of edge cloud is a prelude to the edge infrastructure located between the device and the central cloud, enabling various computing requirements and low latency services of various devices, especially mobile or IoT devices required by 5G. So far, I have covered various aspects of open ecosystem around 5G. In conclusion, 5G is leading the convergence between industries and markets beyond the existing scope. Doing so requires new openness-based standard and ecosystem to guide and promote the integrations. However, I must admit there are many barriers to overcome to achieve the rosy picture I just explained. So I wish all of you could play major roles in leading these open innovations. That closes my presentation. Thank you.